Chapter 7 Probability. At the end of the lessons, students should be able to define the concept of experiment, outcomes, events, sample space, and random selection. State the basic law of probability. Find the probability of an event. Find the probability of the intersections and unions of two events.
So suppose that there is a blue, a red, and a black pen. What is the chance of choosing a black pen?
That is an example of how you use probability.
So the definition of probability is the chance of an event occurring, playing games or observing the occurrences events. So for example, probability is used widely in number forecast, lotteries, slot machines, card games. It is also used in fields of insurance, investment, weather forecast, economic planning, marketing, finance, and business. So what is random experiment? It is a process leading to at least two or more possible outcomes. Uncertainty as to which outcome will occur. We don't know what outcome will occur. For example, if we toss the coin, so we don't know if we're going to get a tail or head. When a die is rolled, we don't know what number will come out. It's either number 1, 2, 3, 4, 5, or 6. Or another example, when a customer is asked which one of the two products he or she prefers. Okay. Then what is outcomes? So outcome is possible. Okay, outcome. Okay, what is outcomes? Possible outcomes of a random experiment are called the basic outcomes. For example, just now I said about a coin is tossed, kan? So bila kita toss a coin, we're going to get either a head or a tail. So head or tail is the outcome of the random experiment. Okay. So sample space, what is sample space? A set of all basic outcomes. Okay, event. So what is an event? Event is a set of basic outcomes from the sample space or the experiment. An event is a subset of the sample space. Okay, simple event that includes one and only one outcomes from an experiment, and compound events, more than one outcomes. Okay, we're going to look at the example. Example 1. So if the experiment, if we toss a coin once, so what is the possible outcomes? So the possible outcomes are head, either way we're going to get a head or tail. So sample space is all possible outcomes. So we're going to put head or tail lah. So event, so apa event dia? So let's say the event is getting at least one head.
So event kita ni adalah simple event since we only have one outcome.
So second experiment, tossing a coin twice. So the possible outcomes are head head, head tail, tail head, or tail tail. So sample space, as I said just now, is the list of all possible outcomes. So we're going to put with the curly bracket. So let's say the event is getting at least one head. So the compound event, the event of getting at least one head is just 3. It's either we're going to get or both head tail, or the first one is tail and the second toss baru kita dapat head. The third experiment is rolling a die once. So if we roll a die once, the possible outcomes are 1, 2, 3, 4, 5, and 6. So the sample space, kita akan listkan all the possible outcomes into the curly bracket. Okay, let's say the event A is event of getting a prime number. So what is a prime number? A number that is greater than 1 and can only be divided by itself. So 1 tak include lah. Number 2 is a prime number. Number 3 is a prime number. 4 is not a prime number because it can be divided by 2. 5 is a prime number. 6 is not a prime number because it can be divided by either 2 or 3. So the compound event is 2, 3, and 5. We're going to put it in the curly bracket. Okay, the fourth experiment or the last experiment, taking a drive test. So the outcome is either we're going to pass or fail. So the sample space is pass fail is put in the curly bracket. Okay, sample space for an experiment can be illustrated on a Venn diagram, tree diagram, or a table. So for example 2, the experiment is tossing a coin twice. Okay, so when we talk about tree diagram, it must start from the same beginning. So starts from here. The possible outcomes are either we get a head or we get a tail. But that is just for the first toss. So we have to toss the coin twice. So for the second toss, the first toss we get a head. So the second toss, there will be 2 possible outcomes. It's either getting a head or getting a tail. Same happen when we get tail in the first toss. When we toss the coin twice, at the second toss, we might get a head or we also might get a tail. So the possible outcomes are head or head tail or tail head or tail tail. So this is how we put our sample space. So Venn diagram, what is a Venn diagram? So we're going to put all our outcomes in a circle. Okay, S means sample space. So if we illustrate our experiment in a table, okay, we can also illustrate our experiment by using table. So let's say this is our first toss. This is our second toss. Okay, so if our first toss is head and our second toss is also head, so we're going to write our answer, our outcome as head. If our first toss is tail and our second toss is head, we're going to write our answer as tail head. Same goes if we have first toss as head, second toss we get tail, so we're going to write our answer as head tail. And if we get both first toss and second toss tail, so the way we're going to write our answer is tail tail. Okay, next, the experiment of getting odd numbers when rolling a die once. We know that a die, when we roll a die, the outcomes are 1, 2, 3, 4, 5, and 6. Okay, but the event of getting odd numbers, nombor ganjil, is number 1, number 3, and number 5. So the possible outcomes of getting odd numbers is 1, 3, 5. Okay, so this is a tree diagram. Okay, there are 6 possible outcomes. Okay, if we illustrate our experiment by using Venn diagram, so we know that the sample space, if we roll a die, there are 6 outcomes, 1, 2, 3, 4, 5, 6. But since the event is just getting odd numbers, so the circle means odd numbers. So the odd numbers are 1, 3, and 5. So other than the odd numbers, which is the even numbers, we're going to put it outside the circle, but still within the sample space. Okay, so that's why 2, 4, and 6 is put outside the circle. And there is no, we can't illustrate this experiment by using table. Because usually we're going to use table when we have like 2 categories. Okay, but if we roll a die, we don't have 2 categories. Alright, third experiment. A bag contains 3 red balls, 2 blue balls, and 5 yellow balls. The experiment is to draw a ball from the bag. Okay, so we're going to draw 1 ball from the bag. So the possible outcomes is either we're going to get a red ball, a blue ball, or a yellow ball. So the outcome is red or blue or yellow. Alright, so to illustrate using Venn diagram, so the sample space, okay, we draw the sample space. So inside the sample space, we have 3 possible outcomes, either the red balls, the blue balls, or the yellow balls. Okay, there are no other colors lah. So that's why there is no other number of or letters outside the 3 circles. Okay, and we can't use table to illustrate the experiment since, like I said just now, we don't have two categories, different categories. Okay, so another experiment to look at, 2 dice are tossed. When we toss a die, we know that we're going to get, we know we're going to have 6 possible outcomes, 1, 2, 3, 4, 5, 6. But since we have 2 dice to be tossed, so we're going to consider the first toss and we're going to consider the second toss. For the second toss, we also have 6 possible outcomes, 1, 2, 3, 4, 5, 6. So the outcomes will be 1, 1, or first toss 1, second toss 2, or third toss 1, second toss 3, and so on. Okay, we cannot use Venn diagram to illustrate this experiment, but we can also use table. Okay, even though we have the same category, but there is 2 events going on, toss first die and toss second die. So when we toss first die, we get 1, toss second die, we get 1, to write our outcome as 1, 1. When we toss the first die, we get 2, toss second die, we get 1. So we're going to get, the outcome is 1, 2. And so on, just fill in the table. So overall, for this experiment, we have like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6 times 6, 36. Based on the table, we're going to get 36 outcomes from this experiment. Okay, so it is much easier to use table compared to use tree diagram for this experiment. So it actually depends on the experiment that we have. Certain experiment, so actually it depends on what experiment we have. Sometimes it's better to use tree diagram, especially when it involves flow of events or flow of actions. And we usually use table when we have like 2 categories, 2 different categories. Yeah. Or 2 things at the same time. Then we use table. Okay, next, we're going to have a look at the definition of probability and basic laws of probability. So the probability of an event A occurring is denoted by PA. Okay, so the definition of PA is number of possible outcomes in A divided by total number of all possible outcomes in the sample space. So we usually write as NA over N as S represents the sample space. So basic laws of probability. Okay, the probability of A is in between 0
to 1.
If we have PA equals to 0, meaning that the event is an impossible event, impossible for the event to happen. If PA equals to 1, meaning that the event is a sure event, surely that event to be happening. Okay, and PA prime, A prime means that the probability A doesn't happen. So PA doesn't happen plus probability of A equals to the total probability lah. And we know that the total probability is 1. The sum of probabilities of all events for an experiment is always 1. Finding the probability of an event. So we look at example 3. So a box contains 8 white chalks. A teacher is drawing a chalk from the box. Find the probability that the chalk is white. Okay, so let W be the event of drawing white chalk. Okay, so number of sample space 8, since there is 8 chalks altogether in the box. Okay, number of available white chalk is 8. So probability of getting white chalk when we draw chalk from the box is number of white chalk divided by number of all chalks in the box. So the answer is 8 over 8, which equals to 1. So when we get probability equals to 1, meaning we're definitely going to get a white chalk when we draw from the box. Okay, not white. So not white, meaning we have to find probability W prime. It also means 1 minus probability of W. So 1 minus probability of W, which is 1. So 0.
It is impossible not to get white chalk.
Okay. Let B be the event of getting blue chalk from the box. So B is an impossible event, tak mungkin terjadi. So the probability of getting a blue chalk is 0.
Example 4. Two dice are tossed. Find the probability that A, the sum of two numbers, is 8. Okay, so for this experiment, we're going to use table. Okay, this is what your table should look like. For the first row, we're going to put the first die. For the first column, we're going to put the second die. The outcome is sum of the outcomes when we toss the dice. Okay, when we get one as a when we toss first die we get 1. When we toss second die we get 1. So the sum of those two numbers is 2. When we toss the first die we get 2. When we toss the second die we get 1. So the sum of those two numbers we get 3. And we get 4, 5, 6, 7 and so on. Alright, so we get first die 1, second die 2, 1 plus 2, we get 3. First die 2, second die is 2, so 2 plus 2 we get 4, and so on. That is how we fill in the tables. But right now, the question asks us to find the probability when the sum of the two numbers is 8. So let's have a look. When will we get sum 8? So this is the time when we get sum as 8. Alright. So let A be the event of getting 8 as the sum of two numbers. So in this case, we're going to get A when our first die is 2, second die is 6, or when our first die is 3, second die is 5, or when the first die is 4, second die is 4, or when the first die is 5, second die is 3, and lastly, when the first die is 6, the second die is 2. So probability of getting 8 as the sum of two numbers is 1, 2, 3, 4, 5. 5 over number of sample space. So altogether we have 36 sums. So 5 over 36. This cannot be simplified, so our answer is 5 over 36. Okay, next, B. The sum of two numbers are prime numbers. So prime numbers is a number that is greater than 1 and can only be divided by itself. So the prime numbers is 2, 3, 5, 7, 11. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So B is the event of getting prime numbers as the sum. So number of getting prime number is 15. 15 times. So probability of getting B equals to 15 over 36, which can be simplified as 5 over 12.
Example 6. Suppose that a die is biased or loaded so that 3 appears twice. but the other 5 outcomes are equally likely. What is the probability that an odd number appears when we roll this die? Okay, biasa kita jumpa unbiased die. So, bila unbiased die bermaksud probability untuk dapat setiap number tu 1, 2, 3, 4, 5, 6 adalah sama. 1/6, 1/6, 1/6 and so on. Bila kita jumpa case di mana a die is biased, bermaksud die tu, dadu kita tu dia dibina so that berat kepada certain number. Macam case ni, die is biased so that 3 appears twice. Bermaksud bila kita baling, kemungkinan untuk nombor 3 terkeluar lebih banyak. Okay, so kita tahu kita ada 6 outcome. 1, 2, 3, 4, 5, 6. Okay, so kita tahu probability untuk dapat 3 ni 2 kali daripada yang lain. So, mungkin kalau yang lain tu probability dia P. Probability untuk dapatkan nombor 3 adalah 2 kali P lah. Dan dia kata the other 5 outcomes are equally likely. Sama yang lain. Okay, so dia tanya dekat sini, what is the probability that an odd number appears when we roll this die? So, odd number, nombor 1, 3, 5. Alright. So, first kali kita kena carilah P ni berapa. Kita tahu summation of all probability equals to 1. So, P plus P plus 2P plus P plus P plus P equals to 1. So, 1, 2, 3, 4, 5. 5 tambah 2, 7. So, 7P equals to 1. 7P equals to 1. So, P equals to 1/7. So, ini adalah value of P. So, kita nak cari probability odd number. So, probability of getting odd numbers is when we get number 1, when we get number 3, and when we get number 5. So, probability of getting 1 is P lah, which is 1/7. Probability of getting 3 is 2 times P, so 2 times 1/7, plus probability of getting 5, which is P, 1/7. So 1 plus 2 plus 1, kita akan dapat 4/7. So this is the probability when the odd number appears.
At the complement of event A. So this can be illustrated by using Venn diagram. So in this Venn diagram, we can see that there is event A in the circle, and outside the circle we have event A prime. What is event A prime? Event A prime is not A. Okay, but it is still within the sample space region. So what is the probability of A prime? So A prime meaning the complement of event A, not an A. Alright, it consists of all elements in the S that do not belong to A. The possibility that A will not occur. Next, we're going to have a look at unions and intersection of event. So additional probability rules, probability A union B equals to probability of A plus probability of B minus with the probability of intersection between A and B. So probability A union B is the union of A and B, which is the set of all elements that belongs to A or B or both. So please take note that probability A union B equals to the probability of B union A. So if we illustrate using Venn diagram, we can see the shaded region is what we mean by probability A union B. Next, we're going to have a look at PA intersect B. So what is it? It is the intersection of A and B, where it is the elements in common with the A and B. So please take note that PA intersect B is also equal to probability of B intersect with A. So as we can see in the Venn diagram, so A intersect B is just this region. What if we have 3 events, A, B, and C? If we find the union between all these 3 events, PA union B union C equals to probability of A plus probability of B plus probability of C minus with the intersection between A and B minus intersection between B and C minus intersection between A and C and plus intersection between A, B and C. Okay, so if we follow the formula, we can get the probability of this shaded region. Okay, what does it mean by A intersect B equals to empty sets? It means there is no intersection between A and B. A is a subset of B. It also means A intersect B equals to A, meaning the whole A is within event B. Next, we're going to have a look at the De Morgan rule. So what is De Morgan rule? Probability of A prime union B prime equal to probability of A intersect B prime. Okay, and probability of A prime intersect B prime is also equal to probability of A union B prime. So De Morgan rule can be seen from the Venn diagram. So right now we're talking about A prime union B prime, not an A. So if we can't remember the De Morgan rule, we can also find the meaning of probability A prime union B prime by using Venn diagram. So first, A prime, what does it mean by A prime? Not an A. So we try to shade the region which is not an A. Okay, next, the events involved is B prime. So next we try to shade not B. So everything is not B, everything outside B. Alright, so we know that when we talk about union, it means set of all elements that belongs to A or B or both. So in this case, it is set of all elements that belong to A prime and B prime or both. So as we can see here, it means everything in this region that is shaded. So everything in the sample space except for the intersection between A and B. So that's why P A prime union B prime equals to probability of A intersect B prime. Everything that is not A intersect B. So we try to do the same for P A prime intersect B prime. So we shade the events involved, which is A prime and B prime. So event A prime is not an A. Okay, I shade it using the blue pen. And event B prime is not event B. Everything is not B. So I shade it using red pen. So when we talk about intersection is the set of elements in common with A and B. So here, the set of elements which is in common with A prime and B prime. So the area which has common elements is the one outside where we can see there's overlap between the red and the blue pen. So as we can see here, the shaded region is everything except for A union B. So that's why we get PA union B prime. Okay, next we have contingency table. So for contingency table, the first row, we're going to put A and A prime in the first row, and we're going to put B and B prime in the first column. So the entries are as follows. Okay, so the first row, first column is probability of A intersect B. First row, second column is probability of A prime intersect B. Second row, first column is probability A intersect B prime. second row, second column is probability A prime intersect B prime. Total probability for the first row is probability of B. Total probability for the second row is probability of B prime. Total probability for the first column is probability of A. Total probability for the second column is probability of A prime. So if we sum probability of A and probability of A prime, we should get a total 1. Next, exhaustive events. So the two events A and B are said to be exhaustive events if number of A union B equals to number of sample space. For example, we have A1, A2, A3 up to A7. So the number of A1 union A2 union A3 up to A7 equals to the number of sample space. Example 7. A statistical experiment has 8 equally likely outcomes that are denoted by 1, 2, 3, 4, 5, 6, 7, and 8, where A is 5, 7, where B consists of 1, 2, and 5, C consists of 1, 4, 6, and 8. So we're going to use one of these three methods to illustrate our event. So we cannot use table since we have 3 events. Table is restricted if we have 2 events or 2 actions at the same time. We can use Venn diagram to illustrate these 3 experiments. These 3 events A, B, and C. Okay, so we're going to have 3 circles. So circle A, circle B, and circle C. So why do I make them overlap? Because as you can see, in these 3 events, we have overlapping numbers. So this is event B, this is event A. So event A, there's number 7, but we're going to put number 5 in the intersection between A and B because in B, we also have number 5. So for B, we have number 1. We're going to put 1 inside the intersection between B and C, since C also have number 1. Next, we're going to put number 2. So in C, we're going to put number 4, 6, and 8. So there's still remaining number, which is number 3. So number 3 is put outside the circles, but still within the sample space. So we're going to put a box to represent the sample space. Okay, so are the events A, B, and C exhaustive? So what is exhaustive events? If we look at the previous note, the 2 events are said to be exhaustive events if the number of all the events is equal to the number in the sample space. So since the number of event A union event B union event C is not equal to the number of sample space, therefore event A, B, and C are not exhaustive. Next, we have to find the probability of A union C. When we have P A union C equals to, according to the formula, equal to PA plus probability of C minus probability of A intersect C. So altogether in the sample space, we have 8 numbers. So probability of A, in event A, we have 2 numbers, so 2 out of 8 plus probability of C. So in event C, we have 4 numbers, so 4 over 8 minus the probability of A intersect C. So as you can see here, A does not intersect with C, so there is no intersection between A and C, so minus 0. So 2 over 8 plus 4 over 8, we're going to get 6 over 8, which can be simplified as 6 over 8. Example 8, given A and B are two events where probability of A equals to 1 over 3, probability of B equals to 5 over 9, and probability of A intersect B equals to 1 over 6. So we have to find probability of A union B. So if we have probability of A union B, we can use the formula probability of A plus probability of B minus probability of A intersect B. So which equal to 1 over 3 plus 5 over 9 minus 1 over 6. So if you calculate using calculator, you should get your answer as 13 over 18. So next, we have to find the probability of A intersect B prime. So what is probability of A intersect B prime? So it's either you use the Venn diagram to find probability of A intersect B prime, or you can just refer to the contingency table. So according to the contingency table, okay, probability of A intersect B prime is here. So we can find probability of A intersect B prime if we subtract PA intersect B from PA. So PA intersect B prime equal to PA minus PA intersect B. So PA equal to 1 over 3 minus A intersect B, so which is 1 over 6. So we're going to get 1 over 6 as the answer. So next, C, probability of A prime union B prime. So according to the De Morgan's rule, so this equal to probability of A intersect B prime. So what is probability of A intersect B prime? So it is not probability of A intersect B. So 1 minus probability of A intersect B, which equals to 1 minus 1 over 6, which equal to 5 over 6. And what is probability of A prime intersect B prime? According to De Morgan's rule, it means probability of A union B prime. So what is probability of A union B prime? Meaning probability of not A union B, or 1 minus probability of A union B, which equals to 1 minus 13 over 18, which equals to 5 over 18.